here's some help on graphing some logarithmic functions. So when we're graphing log, for example, log base 3, what we want to think about, which might be nicer, is looking at the inverse. So the inverse of log base 3 of x, so let's look at log base 3 of x, is 3 to the x. Okay, so hopefully from the last video, this might help out. So hopefully you know how to graph 3 to the x, the exponential. So if we do that, so let's pick some points. So 0, -1, and 1. If we pick 0, 3 to the 0 is 1. So that's our one very important point there. So I'm going to make it here in yellow. And then 3 to the first power is 3. 3 to the -1 is 1/3. So it gives us kind of like our starting point. That is our 3 to the x. Now, log is really just the inverse. Log base 3 of x is the inverse of 3 to the x. So if this is our x's and this is our y's, we can flip the values. Okay, flip the values. And so we're going to say our x's and our y's. So our x's are going to be these values. So I'm going to say 1/3, 1, and 3. And then I'm going to take the y values from the top. So at 1/3, y will be -1. At 1, it'll be 0. And at 3, my y's will be 1. Okay, and so look what happens with this graph. So our important point is here at x is 1, y is 0, which is right at this point here. Then at +3, x is 3, y is 1. And then at x is 1/3, y is -1. Okay, so let me just label these points here so you can kind of see it. So this point here is 1, 3. This point here is 3, 1, right? So it's flipped. This is x is 1, y is 0. This is 0, y is 1. And then this point here, this is x is 1/3, y is -1. Then you'll know that x is -1, y is +1/3. So it just flips, okay? So if you're having trouble graphing log, just graph the exponential, the inverse of it, so 3 to the x. Okay, so for example, if you're given log base 5 of x, then you're going to want to graph the exponential 5 to the x, and then flip those points. Okay, so I'm going to finish graphing these, so let me erase these points here. So if you're trying to graph, for example, log base 3 of x plus 3, so my first step is I'm going to graph the exponential 3x, then I'm going to graph my log base 3 of x, so the pink is my log base 3 of x. And then I notice here, +3, that means the log function shifts to the left 3. Right? If I plug in a -3, that's going to make it 0. So I can plug in, if I plug in negative, log can't be 0, right? So what that tells us is that the vertical axis shifts. So normally it's here, right, for log. The log base 3 of x would look like this. Okay, so that's what it would look like. And then, so because it shifts to the left 3, then I move the vertical asymptote to here, because log can never be 0. So that is at x equals -3. Now we just take each of these points we have here and shift it to the left 3 units. 1, 2, 3. Same thing over here. 1, 2, 3. And that gets us this graph here. Okay. And then there are lots of other shifts you can do, right? So let me find another one, and we'll try that out. Okay, let's try this example here. We have negative log base 3 of x plus 2 plus 1. So whenever I start, I like to think about my transformations first. So the negative in front means that it's going to be a reflection in the x-axis. Then we have the +2 inside. That's a horizontal shift, and that's going to move opposite, so it's left 2. The +1 on the outside means it's up 1. So when we're trying to graph this, so if you need to, you can always graph the exponential 3 to the x, then graph the log base 3 to the x using the inverse properties, switching the x and the y's. So 3 to the x is, I know it's here at 0, 1, 1, 3, and 1/3, right? So again, if you need to plug in points, -1, 0, and 1, you could do that. 3 to the 0 is 1, 3 to the first is 3, 2 to the -1 is 1/3. Now, then you just switch the x and the y. So therefore, log base 3 of x is going to be here at 1, 0, 3, 1, and 1/3 here. And then so now that is then the blue, that's my log base 3 of x. So what I'm going to do is I'm going to do all of the transformations. So one way to do this is start with the reflection, okay? Because maybe that way that might help a little bit more. So I'm going to go ahead and erase this here. You could leave it there, right? But just to make it a little clearer for us, I'm going to erase it. And so when I reflect it across the x-axis, I am reflecting it across this line. So this point here, that's like our home point. It's not going to move, right? It doesn't change. But this point is going to flip to the other side. So across the x-axis, this is going to flip on the other side of the x-axis. So it's going to move here. This one's going to move to the top, right? So those are the points that we're focusing on. So we reflected it in the x-axis. Now we know it's moved left 2, so what I'm going to do is I'm just going to move. So remember that our asymptote, we have a vertical asymptote at x equals 0. And so when we shift to the left or to the right, we move that asymptote as well. So we're going to shift it left 2. Now remember, I cannot plug -2 in here because if I do, I'm going to get log base 3 of 0, and we're not allowed to have that, which is why there is an asymptote there. So I'm going to go ahead and erase this one here. Now what we're going to do is we're going to go ahead and move these pink points here, my log base 3 of x, we're going to shift it left 2, up 1. So left 2, up 1, which ends up being here. Same thing for the next point, left 2, up 1. Oh, it ends up being there, so let me do another color because I want to make sure I know which one I'm graphing. And then same thing with this point, left 2, up 1, so it's right there. And then, so I'm going to draw my smooth curve here. And so that is my negative log base 3 of x plus 2 plus 1, right? So again, just to summarize, I graphed the 3 of the x first. I flipped those points to make it log base 3 of x. Then I did each transformation. I would start with the reflection in the x-axis, flipping it over, right? The pink one, we did that. Well, the main one was the blue. Log base 3 of x was the blue. Then we just flip the points to the other side. Then you use transformations, left 2, up 1 for each and every point. So I hope this helps out.